Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P0221 refers to an issue specifically with the throttle position sensor B, which is deemed to be out of range. In Honda Accord models from 2017 to 2023, the throttle position sensors are crucial components that communicate the position of the throttle valve to the powertrain control module, PCM. The PCM relies on this information to optimize engine performance and fuel efficiency. If the throttle position sensor B reports values outside the expected range, it triggers DTC P0221. This diagnostic code can either be confirmed or pending based on the vehicle's diagnostic system. Understanding the implications of a throttle position sensor malfunction is vital for diagnosing potential issues with engine responsiveness and overall vehicle performance. The error code P0221 indicates a malfunction specifically with the throttle position sensor B. This sensor is integral to the throttle body assembly located on the intake manifold and is responsible for relaying the position of the throttle valve to the PCM. In essence, by continuously monitoring the throttle valve's position, this sensor assists in controlling the engine's air intake, thus impacting fuel mixture and overall combustion efficiency. When the sensor detects a voltage that is outside the expected range, either too low or too high, it results in the activation of DTC P0221. Proper functioning of this sensor is critical because its failure can lead to performance issues, including decreased acceleration and increased emissions. The causes behind DTC P0221 can be diverse, yet they typically relate to electrical or mechanical failures associated with the throttle position sensor B system. A faulty throttle position sensor is one direct reason that may result in the sensor reporting out-of-range values. Furthermore, poor electrical connections, either due to corrosion or loose terminals, can disrupt signal transmission between the throttle body and the PCM. Damaged wiring or shorts in the connections could also lead to misleading readings that trigger this DTC. It's crucial to inspect these potential causes thoroughly during the diagnostic process, as they can offer insights into the nature of the problem and aid in identifying the precise solution. Drivers experiencing the symptoms associated with DTC P0221 may observe several noticeable issues. One of the primary symptoms is poor acceleration, which may manifest as a sluggish response when pressing the accelerator pedal. This is often due to inaccurate readings from the throttle position sensor, leading to improper air-fuel mixture and engine performance. Additionally, the check engine light will illuminate, prompting the driver to investigate further. Irregular engine idling can also occur. The engine may surge or stall unexpectedly due to the throttle position sensor's failure to provide accurate feedback to the PCM. Recognizing these symptoms early on can significantly affect vehicle performance and safety, necessitating prompt diagnostic action. The first step in troubleshooting DTC P0221 involves verifying the problem situation by turning the vehicle to the on mode, which powers the electrical systems without starting the engine. The next critical action is to clear the DTC using the HDS, or Honda Diagnostic System, which resets the vehicle's diagnostic codes and allows for fresh data collection. Following this, it is essential to check the parameters of the throttle position sensor B using the HDS again. At this point, a reading of 0.48 volts or less should be recorded for a proper diagnosis. If the reading matches this threshold, it indicates that the failure condition is consistently replicated, which means it's time to proceed to the next troubleshooting steps to further diagnose the area of concern. In the second troubleshooting step, the technician needs to measure the voltage output from throttle position sensor B once again. This time, checking for values of 4.61 volts or higher. This ensures that if there is still a fault present, it can be accurately diagnosed. If the voltage reading falls within this range, it further confirms that the throttle position sensor B is malfunctioning consistently, prompting the technician to advance to deeper diagnostics. However, if the voltage is below this threshold, the issue may be intermittent, and it is prudent to check for loose connections or poor wiring related to the throttle body and PCM. This can highlight issues that aren't apparent during standard checks, making it crucial for a thorough inspection of electrical components. In this troubleshooting step, the technician inspects for both pending and confirmed DTCs via the HDS. They're specifically looking to see if any related codes, like DTC P0121, which signifies an issue with throttle position sensor A, appear at the same time as DTC P0221. If both codes are present, this could indicate a shared failure area or systemic issues in the throttle body system as a whole. This would guide the technician to itemize areas for more focused inspection. If only DTC P0221 remains, then it's essential to perform additional checks on the throttle body and other related wiring to pinpoint the exact failure source. The fourth troubleshooting step initiates a shorted wire check, focusing on the THL2 line while the vehicle is turned off. The process begins by entering the short circuit service mode using the HDS, allowing for proper testing without interference from other electrical signals. Next, technicians must disconnect both the PCM connector E and the throttle body 6P connector before checking continuity between the designated test points. This process examines whether there's continuity between the throttle body connector and the body ground. If continuity is confirmed, then a short circuit in the THL2 wiring is indicated between the PCM and the throttle body, requiring a repair. If continuity does not exist, further inspections of the wiring may be warranted to ensure other components are functioning correctly and are free from damage. Step 5 focuses on determining potential failure areas surrounding the throttle body itself. The technician should first disconnect the throttle body 6P connector and then turn the vehicle to the on mode once more. After doing so, they are required to measure the voltage between two specific test points within the throttle body connector. This testing seeks a reading of approximately 5.0 volts. If this check reveals the expected voltage, it indicates that the throttle body is malfunctioning and requires replacement, as it's unable to produce the necessary output signals. Conversely, if the readings are inconsistent or do not show the expected voltage, the diagnostics need to continue to determine where the potential loss of function occurs within the system. In Step 6, the technician executes an open wire check focusing on the VCC3 line, which connects the throttle body to the PCM. To begin, the technician must first turn the vehicle to the off mode and enter the short circuit service mode using the HDS. Afterward, they disconnect the PCM connector E. With both connectors removed, the technician can then assess continuity between the noted test points. If continuity is established, this suggests that the VCC3 wire is intact and functioning correctly, directing the technician to consult additional service information for insights. If there is no continuity, however, it indicates an open circuit somewhere in the wiring, necessitating repairs along the VCC3 line between the throttle body and the PCM connections. The seventh troubleshooting step circles back to the examination of any additional pending or confirmed DTCs in the system through the HDS. Technicians must assess whether the previously mentioned DTC codes P0121 and P0221 appear together again. If they do, it suggests a more significant issue affecting the throttle position sensor system could be at play. Conversely, if only DTC P0221 remains, it leads the technician to proceed to more targeted diagnostics. This methodical approach helps narrow down potential failure areas, which is crucial when multiple DTCs are indicated, ensuring appropriate corrective measures can be applied without unnecessary replacements. In Step 8, the technician reiterates the diagnoses by disconnecting the throttle body 6P connector. Following this, the vehicle is turned to the on mode for voltage measurement between specified test points once more. The objective is to identify if there is approximately 5.0 volts present. If the correct voltage is achieved, this suggests that the throttle body is effective in its function, necessitating further diagnostics to find any underlying issues. However, if the readings are not what is expected, a replacement of the throttle body would typically be the next recommendation. This step reinforces the importance of verifying component functionality through systematic testing. Step 9 encompasses performing an open wire check, this time focusing on the THL2 line. To initiate this check, the vehicle must be in the off mode, while again employing the short circuit service mode using the HDS. The technician disconnects PCM connector E and assesses continuity between specified test points once more. If continuity is identified at this step, it indicates that the THL2 wire is intact, and further inspection may be warranted to check additional systems or components. Conversely, if continuity is not present, it signifies an open circuit that requires immediate attention and repair of the THL2 wire, connecting the PCM to the throttle body. In the final troubleshooting step, the technician conducts an open wire check targeting the SG3 line, essential for the proper function of the throttle body system. The process begins with placing the vehicle into the off mode and jumping the SCS line using the HDS for empowerment. Disconnecting the PCM connector E and the throttle body 6P connector follows, providing the necessary access to check continuity between specific terminals. If continuity is found, it indicates that the SG3 line is functioning properly, and other components may require analysis. If continuity is absent, repair of the SG3 wire between the PCM and throttle body becomes crucial to restore functionality, thereby completing the comprehensive diagnostic approach. After all repairs and replacements related to DTC P0221 have been made, it is imperative to conduct a final verification of the repairs undertaken. This involves performing a thorough road test to ensure the vehicle operates as expected, with smooth throttle response and no stalling or sluggish performance. Additionally, post-road test, it is essential to utilize the HDS to scan for any recurring DTCs, ensuring that none of the previously indicated trouble codes, such as P0221, reappear. If all tests validate the effectiveness of the repairs and the vehicle performs optimally, the repair process is deemed successful. Final checks not only confirm the quality of work, but also help increase customer satisfaction by restoring vehicle reliability and performance. Preventive maintenance plays a vital role in avoiding issues like DTC P0221 in the future. Regular checks of electrical connections related to the throttle position sensors can help preemptively identify loose or corroded terminals, which could otherwise lead to intermittent faults. Inspecting the wiring harness for any signs of wear, fraying, or other damage should also be part of routine vehicle maintenance. Additionally, maintaining a clean throttle body can prevent issues related to sensor feedback and airflow restriction. By proactively performing these maintenance actions, you can improve the longevity and reliability of your vehicle's performance, thereby reducing unexpected repairs and enhancing overall driving experience. In summary, DTC P0221 highlights a significant concern related to the throttle position sensor B in Honda Accord models from 2017 to 2023. Understanding the roles of the sensors and the symptoms related to malfunctions is essential for timely diagnostics. Recognizing symptoms such as poor acceleration, irregular idling, or a check engine light provides insights for more directed troubleshooting. Systematic diagnostics that involve step-by-step troubleshooting lead to clear identification of the problem areas, whether they be electrical connections, damaged wiring, or sensor failure. By being diligent in diagnostics and maintenance, owners and technicians can ensure that their vehicles operate at peak performance while minimizing future complications. Please like and subscribe to the channel. See you next time.